Okay, in last class we have seen how to create data frames and how can we read read any files and how can we write back to any farm any location we have seen. So from today we will discuss on discuss transformations. How can we perform? How can we create data frame and on top of it? So either you will read from some file or you will create some hard coded data on top of it. So you will do some transformations, right? So that we will see. So how we will clean, how we will transform, how we will process the data. So from now we will discuss everything related to processing of data, manipulating of data, and cleaning of data. Okay. Today we will discuss with column and with column renamed when and otherwise. If possible, we will discuss filter and where also. Okay. So till now we went very slowly, but from now, so we have to complete this course now very early. That's why I will take 1.5 hours to 1 hour 40 minutes so that we can complete early. So you can start you can start practicing for interviews and you can attend interviews. Okay. Today we will discuss on about with column function. Okay, so we use this with the column function to add a new column to a data frame. To we already have one existing data frame, right? So on top of it, if you perform this operation, so this for we can add a new column. So if you want to add new column, you can add a new column to it. Otherwise, so you can update existing data frame and you can modify existing data frame. So we can add new column or we can update no, we can update existing column. Okay, here also we can modify existing column. Okay, so it is a transformation function, which means it requires a new data frame with the changes applied. Okay, so what we can say, so it is a transformation function, which means it returns a new data frame with changes applied. Okay, we will discuss, don't confuse. So why we use this with column is one of the transformation function. So either to create new column or to update existing column or to modify the existing column, we will use this with column. We will see. Okay, everything we will see. Yeah, the syntax will be okay. So we will have one data frame, right? So data frame, on top of it, we will apply this function with column. And we will have two parameters. One is first parameter is column name. Okay. So first parameter can be column name. Either it can be a new column. If you want to create new column, you will give new name, new column name. If you want to modify existing column, so you will use same column which existed before. Okay, column name. First parameter will be column name, and next parameter will be so expression. Okay, column expression. Okay, I mean what we can say expression or value to compute the new column. Okay, so first parameter will be column name, either new column or existing column you will use here. So this one here you will apply some transformation, right? That expression or value to compute a new value, new column. Okay, that one we will provide here. So if I explain one function, right? So on transformation you will understand. Okay, let me create a data frame first. So you know how to create data frame, right? Here, ID, name, and salary. And second one also, ID, name, and salary. Third one also, and fourth one. Okay, three, Shari, 3000. Here four, David. Here 2000. Okay, here we can use Anil. Yeah. So this is the data input data. So there are four rows, and the columns are first columns are list of items, right? One is ID, name, and third one salary. You know how to create data frame. So data frame equal to spark dot create data frame and to this data comma columns. Let's run this. Yeah, it has created required columns and data. Okay, so it has created data frame. So on top of this data frame, we are going to apply this with column function. Okay, so first one, what I want to do, I want to add a new column. I want to add a new column. Okay, what I can add. Okay, so let me create data frame one and df. Okay, so on top of existing data frame, we have to perform, right? So you can see if you type with column, so with it will give you intelligence. So okay, so with column is existed, and if you keep cursor here, it will okay. So keep cursor here, it will give you intelligence. What can be inside this one? Everything it will give you. So here you can see it returns a new class data frame by adding a new column or replacing the existing column that has the same name. Okay, so it means you can use new column name or existing column name, and the parameters you can see in the first row, you can see define with column, and first parameter will be column name, and second parameter will be call. Col means expression. So expression or something. So some operation you will apply, right? That one we have to pass. So first parameter will be column name, right? So I want to add new column. So I want to add user call developer. I mean, who is working on this one? So I want to add developer this one. I not developer, maybe source. Okay, so what is the source of this data? So in this one, we haven't in this in we have three columns: ID, name, and salary. But I haven't added any source, right? From which source we are getting this data? Maybe you can use. So source will be only one, right? So you can use ADLS or some external API or a SQL database. Now the source I want to give it as okay. mm, Source can be some constant value I want to add. What can I add? So we can use this lit function to add constant literal. Okay. So lit, okay, we have lit function. So where it what it will do, it adds constant literal. Okay. Constant literal to it. Okay. I want to add source as hard coded. So this is hard coded data, right? So hard coded I want to add. Okay, understood, right? This lit function. So lit function, what it will do, the behavior of this lit function is, the usage of lit function is whenever, so if you have a requirement to add constant value, so whenever you want to add constant value to the data frame, or if you want to concatenate some constant value to any string, that time you will use this lit function. Okay, yeah, here I want to add source as new column I want to add. So with only one, I want to add same name to all the rows, right? So that's why I'm using constant literal function, that is lit. Okay, df1 dot show. Okay. So now it will fail because it is not defined. So what we have to do, so I already told, whenever you are writing something, just add everything. I mean, so add import all the functions. Okay, import all the inbuilt functions from pyspark.sql.functions. I want to import lit. If you import lit, yeah, now you will not get error. Okay, see here, so you have ID, name, and salary. This one we already added, right? So this is the original data frame. This is the original data frame. We have columns ID, name, and salary. So ID, name, and salary we have provided. Now we want to add new column. So the source column we want to add. So now you can see the source is added using with column function. So the behavior of the usefulness of this with column is we can add new column by giving constant value. So you can ask me, Gopi, by we do we need, so in many times we will have we don't add same name to all rows, right? So then that time how to do it? So we will see. Okay, so here I want to add constant value. So like this you can add. Otherwise you want to add country as India. You can add. Yeah. So whenever you have a requirement of adding same value to all the rows, na, then that time you can use a lit function. Okay. Next, you want to now we have added new column. So if you have a requirement to um, modify the existing column, so how can we modify? Okay, we have salary column, right? So think like that. So this year our company performed very well, so there is a hike of 20%. So then how our salaries will change? So that time, so salary will not be three this one, right? Salary will not be 5,000, 4,000, 3,000, and 2,000, right? So we have a hike up 20%. So then that time our salaries will increase, right? So how can we do that? df2 equal to df1 dot with column. I will take old df only, existing df only. Df dot with column. And so I want to no need to add new column, right? Because we already have salary column. So on top, I will change this salary column only. I will modify the existing column only. How can we modify? So first parameter is column name. So column name is salary only. So second parameter will be expression. So I want to modify this one, right? So column salary, we already have column salary. So this one multiply with, so how much I have to, how much hike is there? 20%, right? So I will multiply with 1.2 and df2 dot show. So this time also we will get error. Yeah, because column is call function is not defined. That's why I usually what I will do. So I don't import the function which we need. I will import everything. So no need to run this one every time. Okay, I will import everything. Now see, so we have a exit. We have a what? We have original data frame. It has ID, name, and salary. Yeah, ID, name, and salary we have. So and for Anil, the salary is 5,000, but now he got 20% hike na. So his salary will be 6,000. Bobby for him 4,000. It was increased by 20%. Okay, same with Achari and David also. So we can modify the existing column also. Okay. Yeah. So if you want to use, okay, what we want to do, we want to create one new column from the existing column. I mean, we want to create derivative column from the existing column. How can we do? So we will use some functions or some expression. Let's discuss. Df3 equal to df dot with column. Okay, so what I want to do, so I want to convert all the names to uppercase. Okay, now the names are like normal. This one, first letter digit is first letter is capital, and other letters are uh, small case. So I want everything to be in uppercase. How can we do? Okay, so here I will create one new column with the name upper name. Okay, so name upper. Okay, so this name upper will depends on this name column, right? So on top of this name column only, using this name column only, we have to modify this one. Okay, we have to create this one. Okay, we will use this existing name column and we will create name upper from this. So here we already see we have seen. So on top of string, we can apply upper function, right? We have in Python, we have upper function. So just apply this upper function on name column. Okay. Name upper column 1, 2, 3, 1, 2, 3. It is correct only. Okay. So now df3 dot show. Okay, you can see, so we have the original data frame, this one. So it has created using with column, we have created new column. So the column name is new name upper. Okay. And what it does, so we using this column, we have performed on top of this column name, we have performed upper, right? Transformation. So it converted all the strings to upper. So in Python, you know how to use this upper lower. Okay, yeah. So what we can do, we can create new column, so using some inbuilt Python functions also. Mm, okay, so here you can see, here, okay, here we can see now. Here we can see id is long, name is string, salary is long, and name upper is string. So if I want to convert what Hmm, salary to string. So how can I convert? Okay, so we can do using what using with column function. We can what we can do. So here I forgot to mention. So we can add a new column to data frame. We can modify or update existing column, and we can cast. Okay, so we can change the data type of a column also. How can we modify? Data frame 4 equal to, okay, data frame dot with column. So the column name is salary only. So now see salary, earlier salary column data type is long. Now I want to change it to string. So salary comma the column salary we have to take. Okay, the column salary. And you know, so in Python we have discussed how to change the type. So we can use cast function, right? Cast function and string. No, it is already long, right? So we can use string df4 dot show. So here you can see the same original data frame only, but earlier salary column is long, now salary column is string. So here you can see salary column data type is long. Now the data type is changed to, so we have casted now this column we have casted to string type. So it changed its type to salary. So we can change that, we can cast the data type also using with column. Okay, so yeah, this is okay, but using with column, yeah, okay. So you understood, right? What we can do using with column, why we use with column. So to create new column, to create derivative column, or to update or what modify the existing column and cast the data type, we can use this with column. Okay, many places we will use this with column. Okay, so for now remember that. So for with column we have two parameters. first parameter is column name. Either it can be new name or existing column name. And second one will be expression or operation which you want to perform on. Okay. Um, Now let's discuss about when and otherwise function. Okay. When and otherwise is it is same as like if and else. Okay, so in Python we have if else statements, right? Same here, when and otherwise will work. Okay, same as it is like when and otherwise only. If else block, like if else statement, when and otherwise statements are there. So how it will work? Okay. Yeah, it is used to evaluate. So when function, when and otherwise, so it is used to evaluate conditions and return values based on the condition. Okay, so what it is going to do? Okay, what it is going to do, so whenever we have some condition, and so whenever we have condition, it is evaluate, it is used to evaluate that condition and return values based on the condition. Okay, we will see. So if statements also, what it will do, we will have some statement, right? If that statement is true, if that statement is true, it will execute the code, whatever the block code it is under that if block, it is going to do. So here also what it is going to do, so we will have one condition. If it is successful, it will return the value which we are given. Okay, which we are going to give. So if not, what it will do, if the condition does not satisfy, so it gives otherwise value. So we will in otherwise also we will provide one value. It will return that value. We will see if we see we are going to do some transformation now. That time you will understand. Okay, it is like if and else block. We will have one condition. If that condition is true, then it will return the value which we given when inside when. So if it is not true, that condition is not true. So in otherwise also we will give one value, so it will return that otherwise value. Okay, if it's true, it is give the value which is inside the when block. If it is not true, it is going to give so the value inside the other value. Okay, the syntax of this when and otherwise is when. Okay, when this condition, we will use condition now. When this condition is true, it will give value. So whatever we give here, that value it will return. So if that condition is not true, so we have otherwise also na. So otherwise we can use some other value, some other value. Okay, we can keep like value 1, and here you can keep like value 2. Okay, so we will have one condition. If this condition is true, it will return the value 1 which is inside when block. So if it is not true, it will go to otherwise, so it will return value 2 which we give here. If I explain one example now, that time you will understand much better. Okay, so df dot, I will use the same data frame which we have used earlier. This one only I want to use. Okay. Mm, what we can do. Okay, we have salary column, right? So if salary is greater than 4,000, so I will keep them as a category. We will create. Okay, what I am going to do. So I want to add a new column named grade or category. Category or grade. I will use that category or grade. The name of the new column will be grade. So how I will give, if salary is greater than or equal to 4,000, their grade will be high. Okay. If salary is greater than or equal to 3,000, their grade will be what? Medium. Their grade will be medium. And if salary we don't no need to use 3,000 other condition, because if salary is greater than 4,000 means they will be in high grade. If salary is greater than 3,000 means this one, second one, so 3,000 na, so this one will be medium. Otherwise 2,000, right? No need to add one more condition, so we can use otherwise condition. Then otherwise low. Okay, so when we can use, so if we have any condition, so based on that condition, if you are going to do transformations, then that time you can use when and otherwise. Okay, here we have some conditions, right? Greater salary greater than 4,000, then the grade will be high. If salary is greater than or equal to 3,000, medium. So we have some condition. So we can use when and otherwise block. Let me explain you. Df 5 equal to, we already have df na, df dot with column, and first parameter will be name, right? So column name, first parameter will be column name. I want to add new column named grade. And now, so to this we have to write expression, right? This expression can be, so where, when, okay, when column salary, when column salary is greater than or equal to, hmm, sorry, here, when salary column is greater than or equal to 4,000, then the grade should be high, right? So see the structure, syntax of this. So when condition value one. So condition is when condition is this one. Condition is column salary is greater than or equal to 4,000. So value one is high. Okay, and we have one more this one, right? What, one more condition? So it is like if else if, like we can use two or three if conditions, and if elif and last else, right? Like that we can use here. So we have one more when condition, right? When we have one more condition, so we can use one more when. When column salary is greater than or equal to 3,000. So this is the condition. And next value, one is value, right? So medium, medium. Otherwise, so if both, we have two condition. If it doesn't satisfy both of this, so we will go to else block, right? Likewise, we have otherwise block. In otherwise block, low. Understood? Any doubts here? Df dot show. So we can use this when and otherwise block whenever we have condition. Here I have conditions, right? One is salary greater than 4,000 and salary greater than 3,000. So I want to have grading for that. So I don't need other condition, right? Because we can use otherwise. So yeah, we have three categories. One is high salary, high, medium, and low. So I have used two when blocks and one otherwise block. Okay. Now try to execute it. Yeah. So this is the original data frame, ID, name, and salary. Now I have added grade. So how it is working? We have condition, right? For greater than 4,000. These two guys are having greater than 4,000. That's why their grade is high. And he is having greater than or equal to 3,000. That's why medium. Otherwise, so if it doesn't satisfy both of this, it will go to otherwise. In otherwise, we have value low. So it has given. So so here we have seen usage of with column and when and otherwise. Okay. So when and otherwise normally so use it together with column. So yeah. Okay. So you have seen with column usage and when and otherwise usage. Okay. Mm, Hmm. Okay, what can we create? Hmm. So if you have a scenario like if salary is greater than 3,000, greater than or equal to 3,000, his bonus will be 5,000. If salary is salary value is less than 2,000, then his bonus can be less than bonus will be 1,000. So now how can you do it? So we have the scenario like if salary is greater than or equal to 3,000, his bonus will be 5,000. If salary is less than 3,000, then his bonus will be 2,000 only. So, okay, how can you do that? Using, we can use with column, right? With column, and the column name will be bonus. When column salary is greater than or equal to 3,000, bonus value. So bonus value will be how much? 4,000. Otherwise, so we have only one condition, right? Greater than or equal to 3,000, bonus 5,000. Less than 3,000, bonus 2,000. So you don't use this one. Otherwise, here the value will be 2,000 only. So we have bonus column here. One is what we have condition. So here 5,000 and otherwise 2,000. You can use with column when and otherwise block for that scenario. Okay, understood? Mm, now what with column is completed, when and otherwise is completed, we can discuss about with column renamed. With column renamed. So don't worry about Gopi. How can we know this? These many functions are exist. So you can take help of Databricks. I always suggest you to take so DF, DAR, DF. If you run this one, DAR, so you can see with column is there, with column renamed is there, with metadata is there. So you can find like this what the union is there, union all is there. We will discuss everything, don't worry. Okay, so Gopi, I don't know the structure, I don't know anything of with column. How can you do? So go, you already know with column function is there. Now df dot help, df dot with column, and you can go to this documentation and you can see the, okay, here you can see the parameters. First parameter will be column name. Column name will be in string format, string name of the new column. Okay, new column or existing column you can give. And column, class column, this one is expression for the new column, what expression you want to pass. So it has two parameters, one is column name and column parent, like that. So here also we have with column rename it, right? So you can take help of this with column renamed. Here, the what will be the syntax? Df dot with column, and what are the parameters? First parameter is existing column, so existing, and second one will be new. So what is this existing? Name of the existing column name. Okay, and new one will be, so new name of the column. Okay, so first one will be existing, parameter will be existing column name, and second one will be what you want to, so that what name you want to give for that existing column, the new name you will pass here. That's it. And it what it returns, it is going to return a new data frame with renamed column. Okay, yeah. So you use this help command, it will be better because you are beginners, right? Yeah. So with column renamed is used to rename rename a column in data frame. Okay, so it is used to, so why we use this with column rename? To rename a to rename a one column in a data frame. Existing column we want to change it to some other name. Okay. Mm, yeah, it is also a transformation. function. So it is also a transformation, meaning it returns a new data frame with updated column names. Okay. So if you want to give updated column, any other name, you can use it. Okay. The syntax we already seen, right? Syntax will be df dot with column renamed, and it has two parameters. First parameter is existing column name, and second parameter is new column name. Okay. Yeah. We can use the existing data frame, right? Df dot show. No need to create one more time. It will waste our time. Yeah, we have this data frame. What I want to do, I want to change this salary column to salary monthly. So we will get salary in once in a month, right? So I want to change it to salary monthly. Okay, how can I do it? df6 equal to df dot with column rename. Okay, and the existing column name is salary, right? And a new column name, you can give any name. So here I want to give salary, um, salary monthly. df6 dot show. Yeah, so here you can see, so both data frames are same. The data is same here. 1, 2, 3, 4, Anil, Bobby, Chari, David, and the salary also same. But what it has changed? So it has changed salary to salary monthly. So Gopi, you can ask me, Gopi, why we need this with column renamed? Because sometimes sometimes what will happen, sometimes we will in if you read csv file directly, csv files won't follow the structure of I mean column name structure, right? It can have name like, it can have name like first name. So we can have name column. So we can have a name column like first name. Okay. But database, SQL database are structured data bases. They won't allow spacing, right? You have to give first underscore name, or you have to use first name as capital and second one also capital. So you can use for readability, we can keep like this. So you should not use space here. Okay, in tables, whenever you are creating any table inside SQL databases, it won't allow spacing between column names. That time we need to change this, right? So if you have salary space monthly, so we have to rename it to salary underscore monthly. Okay, and one more thing. So we already have a delta table. We will discuss about delta table later, but delta tables we will use for easy reading. If those tables are okay, so we have what we have. We have incremental loading concept in our incremental loading strategy. So we already have we already have target table somewhere, either in SQL database or here we have one table. So in the table, we have column names like salary monthly. Okay. So ID name salary monthly. But from the input, if you get salary yeah, column names as ID name and salary. So if you want to write it to this table, what will happen? So it won't write, it will throw error because from here the name is salary. But inside the target table, you have salary monthly. So it will say, so column names are not matching. That time we have to rename. So we have to rename the column name so that it will compatible with the target system. So that time, that type of scenarios also we will face where we will face in real time. Okay. Hmm. And one more thing. So from the raw data, so they will not write column names properly. They will write like SAL only. They will not use full name SAL. And sometimes temperature. So they don't use temperature full name. They will use TEMP. We don't know whether it is temperature variable temperature, or it is temp variable. We don't know. Temporary variable. We don't know. So that's why. So for reporting people, the business leaders, they won't read short names, right? They want correct names, full names. That time we have to use not SAL. So we know SAL is salary, but they don't know, right? So they can, and they for whenever they are giving demo or presenting it to the clients, that time they have to know. So whether it is salary or not. So that time we have to we have to change this SAL to SALARY. Okay. So some scenarios we will see. Okay. Mm, for reporting, whenever you are going to report, that time everything should be full name. So you can't use short names. Okay. That types whenever you encounter those scenarios, you can use with column renamed. Okay. Yeah. Mm. Okay, what if you want to change multiple columns? Okay, let me create one data frame. If you want to change multiple columns to rename, you can use def dot with column renamed. Okay, you want to change. We already have existing one ID, right? You want to change it like a employee ID. Because so why Gopi? Why employee ID and employee ID? So there is no change. But but if this data frame, we have one data frame. We also have one sales data. From there we are getting ID, but that ID is sales ID. Okay, so we have one table or one data frame with employees data. We have other data frame with the name sales data. So inside sales also we have ID, and inside employees also we have ID. Both are IDs, but they are not same. This is employee ID, that one is sales ID. We have product table. In product table also we have ID, but that is product ID. So to differentiate all of these, so we need to change them, right? So here we will change this to ID to employee ID. In sales data frame we will change it to ID to sales ID. In product table we will, product data frame we will change ID to product ID. So understood, that time we need. Okay. And we can use multiple times also. If you have one more column to change, here name to, so if you want to name change this one to name to employee name, you can ask me why we are changing. So in employees data, we have name, employee name. In sales data, we will have products data, we can have name column, but it is product name. Okay. Okay. In store, we will have store table. Inside store also we have name, but it is store name. So like that, to differentiate them, we have to change sometimes, not always, but sometimes when you are working with two or three tables, or if you are going to perform joins, then that time we need to rename them. Okay. And I want, if you want to rename this one also, salary to what? Salary to employee salary. Just I am showing, we can change if you have multiple columns to change, rename them. You can change in only one transformation. No need to use multiple times. So you can use with the column renamed. How many columns you want to rename? You can use those many. Here you can see. So employee ID is changed to employee ID, name is changed to employee name, and salary is changed to employee salary. So we can change the multiple columns by chaining. Okay. Mm, with column is completed. With column renamed is completed. When and otherwise is completed. So okay, filter and where we will discuss, right? Okay. Yeah, both are same. Filter and where are both are same. You can use interchangeably. Okay, so both performs same thing. So no change, no because it will filter will have some condition. Where class also will have some condition. So you can use both of these interchangeably. You can use any one of them. So there is no performance issue also. So there is no change in the performance also. So you can ask me, Gopi, if I use filter, is there any performance improvement? No, no. So both are same. Performance also same. Okay, both filter. Yeah, I want to explain filter and where, right? Filter, this filter keyword, filter and where. Okay, these are used to filter rows. Rows are records with rows in a data frame on a condition. Okay, so if you have some condition, if you have some condition on that, on using that condition, if you want to filter out some rows, then you can use this filter or where. Okay. The syntax will be, what will be the syntax? Df dot, you can use filter or where, both are same. You df dot filter, and inside this you will use condition. Okay, or else you can use df dot where inside this condition. Let's see. So we already have one data frame, right? No need to create one more data frame. Df dot show. Yeah, it displayed, right? Yes. What I want to do, mm, I want to filter out whose salary is greater than 3,000. So I want them only. So I want to exclude, I want to filter out the employees which are having low salary. Okay, how can we achieve this? df7 equal to df dot filter. Okay, df dot filter column. So the condition is column salary. Okay, so the column salary is greater than 3,000. So I want to select them only. Okay, let's show this. Here you can see, so we have four rows, but here what I did, so I want to filter those who are having greater than salary value as greater than 3,000. So these two, Anil and Bobby, has salary greater than 3,000, and Chari has not greater than 3,000, right? It is equal to 3,000. That's why it excluded Chari also. So if you give greater than or equal to, so then it will include Chari also. Okay, so if you have some condition, so on using that condition, if you want to filter out some rows, so you can use this filter. Okay, so if I use where one also, same behavior, same thing, no nothing changed. So you can use interchangeably, both perform same. Mm, and if you want to, yeah, here if you want to select only one row, then how can you do? So df8 equal to, okay, df dot filter, we have to pass one condition, right? Column name. So I want only, I want to see whether I want to process the data if the names. So we have many names. If you think of, we have thousand of names. Inside that, if anyone with Anil, I want to process those records only. Okay. Then that time, what will be the condition? So I want to filter on the column name. So on column name where Anil equal name, column name value is Anil. So I want to filter those only. I want to process those only. I want to remove other all other records which are not having Anil as name. So let's see. Yeah. You can see it has processed the records whose value column name value is Anil. It has what it has removed all other rows. Okay, you can use like this. So I have used this two equals because it is not assignment one. It is comparing, right? We are passing inside some condition. That's why we have to use two equals to. So if you use one equals, it means assigning value. But here I am not assigning value. I am checking. So I am checking whether column name is Anil or not. That's why I have to use two columns, a two equals symbol. Mm, uh, Okay, so if I have multiple conditions, then how can we use this filter? How can we use those conditions? So you can use when clause also. Otherwise, you can directly use filter also. So what is the problem with when? Because we have to use with column and together with column we have to use when and otherwise. So instead of using those two transformations, we can directly use filter, right? Df dot filter. So I want to process the records. I want to process the records whose salary is greater than 1,000. Okay, whose salary is greater than 1,000 and less than 4,000. Okay, so whose salary is greater than 3,000 and who salary less than or equal to 4,000 means it has to select these two only. So greater than 1,000 means greater than 1,000. Oh, 2,000 also will be included. Yeah, so 2,000 included and lesser or equal to 4,000. Okay, lesser or equal to 4,000 means it will process these records only. Okay, I don't want to recruit. I don't want to I want to save some cost savings. I want some cost savings. So the company wants to fire the employees with high salary. So they want the employees whose salary is less than greater than 1,000 and less or equal to 4,000. So then that time we can do this, use this filter. Okay, column. So first condition is salary greater than or equal to 1,000, right? So 1,000, and okay, column salary is greater than 1,000 and column salary is less or equal to 4,000. This is the condition. Yeah, let me run this. Df dot filter column salary greater than or equal to 1,000 and column salary less or equal to 4,000. Get object ID. Data frame object has no attribute. Okay, maybe this. Yeah. Okay, both inside these parameters we have to pass because this is one condition and this is one condition. So I have to group them, right? That's why I have to use extra parentheses. Okay, df9 dot show. Yeah, it has passed. It has removed 5,000, right? Because these three fellows, Bobby, Charlie, and David, has salary greater than or equal to 1,000, correct? And their salary should be less or equal to 4,000. Yes. So the employee with 5,000 salary is removed now. Okay. Yeah, it means so why I explained both condition means you can use and condition, or so if you have multiple conditions, then also we can use this filter. Or not only one condition, if you have two or three conditions and you have to combine them, then you can use and or not. Okay, conditions together. Okay, use case will be If you want to remove, so using filter and where transformation, if you want to remove unwanted rows, then you can use, okay, you can use filter or where. Okay, what they will do, they will filter out the rows which you don't want. Okay, like low salaries or nulls or high salaries, if you want to filter out, they will filter out. Okay, select specific, if you want to select some specific groups. Okay, so you can filter by department, or if you want to filter, so if you want to select only the departments to be IT, if you have many departments, IT, HR, sales, marketing. But if you want to process only the IT employees records, then you can filter out using column department equal to IT. And if you want to filter, if you want to process only HR people data, then what you can do, column inside the filter condition. So the condition will be column department equal to HR, like that. Okay. Um, yeah. Yeah, yeah. If you want to remove, if you want to remove the columns, if you want to column name is not null, then you can use filter also. So inside df dot filter, where this column is not null, the condition is column name or column ID is not null. Okay. Those, then if you have those scenarios to clean or to filter out, so you can use filter or where condition. And one more thing, so don't confuse filter and where, both are interchangeable. Use whichever feels more readable to you, or you can use both of these, no problem. Yeah, you can use multiple conditions also, like this. You can combine inside this condition, you can use multiple conditions. If you have only one condition, you can use that one also. Whenever you, yeah, so we have to use this column one, right? So this call is inbuilt PySpark function. Okay, so this one, whenever you want to access some columns, then you will use col, column name, not column function. So this call function you will use whenever you want to operate on these columns, you will use call function. Yes, this is PySpark's inbuilt function. With column is completed with renamed, yeah, when and otherwise, filter and where. Okay. Okay. So now today let's discuss about show also. Show, we have show function, right? So let us discuss about this show function also. This show is an action. Okay. We have some action functions like count, display, show. Okay, we have many action functions. One of them is collect, show, count, display. These are some action functions. Okay, show is an action function that displays what it does. It displays the top rows of a it displays the top rows of a data frame in a tabular format. Okay, so what the function of this show function? It is going to display data. So it is going to display the data inside a data frame. So top rows we can see. Okay, it won't display. It won't display all the rows. Okay, default, by default, it will display 20 only. Okay. Yeah, and it will display in we will have a tabular format. It will display, we will have here, you can see it is like, it is looking like table, right? Will have columns and we will have data rows also. Okay. Why we use this one? We will use it primarily for data previewing and testing and debugging. So we'll use this show function for all of this. Okay, so take help of Databricks. Help show. Mm, okay. Mm, show why it is help show. Okay, show dot help. No, why? Mm. Okay, so I will look why it is because show is also one of the built-in function. It has to give. mm, Let me. Okay, okay. Understood. Df dot show we have to use. So here you can see. Okay, here you can see inside show. Till now we haven't passed any parameters, right? We haven't passed any parameters, so we can pass some parameters. So first parameter can be n. So n means so number of rows you want to display. Default it will display only top 20 rows. Okay, if you want to give a number of n value as something, so by default it will be 20. And truncate also, so truncate means it will by default it will display 20 characters only. If you have more than 20 characters now, it is not going to display for you. Okay, it will truncate. And vertical means if you want your data as horizontal or vertical. So if you give vertical as true, it will display your data vertically. Let's see everything of this. Okay, data one Anil. Okay, Anil, like this, it is greater than 20, right? Yeah, 1 2 3 4, yeah, greater than 20. And yes, let's d let's run this first. Now df dot show. So if you run this, what it is going to do, let's see. So it has displayed, if you can see Anil, it has displayed only 20 characters. After 20 characters, what it is going to do? So it is going to truncate. So that time what you have to do? So here inside show function, you have to give truncate equal to false. If you pass this parameter, what it is going to do? So it will display everything. Okay. By default, if you don't pass this truncate equal to false, by default it is going to display only 20 characters. So I kept truncate equal to false. That's why it displayed everything. If you give truncate equal to 7, what it is going to do? See, so it has Anil name is very big, but it has given truncate equal to 7 means only the 7 characters, first 7 characters it is going to display. If I give 5, what it is going to do? Here you can see, so Anil an only displayed. It has many characters, right? That's why other, so it displayed only first 5 characters. But it is saying dot means it is indicating Anil name is not only 5, Anil name is not ended at 5. That's why it is dot. It is saying more than 5 characters he has. That's why it is indicating with this. Okay, Bobby and Charlie and David, they have 5 characters. That's why it displayed everything. If I give 4, what it is going to do? See here, only first character it has displayed. So Anil. So Anil and many characters are there. That's why dot dot dot. Bobby also. So Bobby B and three dots means it is not four characters. It has five characters, right? That's why dot dot dot. Other character also there. So this truncate you can use like this. If you want to display everything, you can use truncate equal to false. Okay, if you want to display only the few characters, you can give any number. Okay, here first parameter can be this number of rows. If you want it by default, if you won't provide that one, so by default it will be 20. So if you give some two only, so what it is going to do, it will display only first two character first two rows. If you give 22, it will display only 22. Okay, if you don't provide anything, it won't display. It will display only 20 if you by default 20. And if you want to pass other this one also na parameter vertical equal to true. If you pass vertical true, now our data will be displayed vertically, not horizontally. See here, first record ID is name one Anil 5000. Vertically it will display, not horizontally. Okay, so in this show function, what parameters we have? First one is how many number of rows you want to display. Second one is whether you want to truncate this or not. And third one is what? Third one is what? Vertically or horizontally. You can ask me, Gopi, what is the difference between show and display? Show is PySpark or Python's this one, Python's function or PySpark function. But display is Databricks function. Okay, it will work only in Databricks environment. Okay, it will not work in other PySpark environments. So maybe you can use PySpark. You can build notebooks, or you can use PySpark in other of platforms like Google Cloud or Jupyter, but there you cannot use display. Display we can only use inside the Databricks. And other tools you cannot use. Okay, that is the difference between what show and show you can use anywhere. Show you can use in all PySpark platforms, but display you can use including PySpark, but it should be Databricks. Okay, okay, yeah. Display is particularly for Databricks. What we can discuss now, everything we have covered. So these all I thought, I don't know. So whether I am going fast or slow, I don't know. But whatever I want to discuss today, I have discussed. So if you have any questions, we can discuss for next few minutes. Otherwise, we can end the session. So how are you feeling, guys? So it is okay. This pace is okay. Okay.
Yes, yes, sir, yes.
Okay.